Hi everyone, in this video we'll take a look at a question 6 from a step 2 paper from 2010. The question gives you a tetrahedron of each edge unit length, so each edge has length 1, and P is directly below D, so D is vertically above P, and the question asks you the length dP, so this length. I'm going to start by labeling the vertices. I'm going to employ vector calculus, so I'm going to call this this direction x-axis, and coming out of the page is the y-axis, and going up is the z-axis. I'm going to say A is the origin, so I'm going to say A is a 0, 0, 0. Therefore, I'm going to say that C is along the x-axis. So C becomes 1, 0, 0, and B becomes, if you employ Pythag in this triangle ABC, B becomes a half and root 3 over 2 and 0. So to find dP, I know I can employ Pythag in this triangle. I know because P is directly below D, this is a right angle triangle, and I also know that AD has unit length, so it has length 1. So if I work out AP, then I can use Pythag to work out dP. First off, I have to find the coordinates of P. It is given in the question that P is the midpoint of ABC, the plane ABC. So P is given by, therefore, a third of the sum of all these coordinates, so the sum of A, B, and C. So that is 3 halves root 3 over 2 and 0. Therefore, P is given by the coordinates a half root 3 over 6 and 0. Therefore, the length of AP squared is given by a half squared plus root 3 over 6 squared plus 0 squared. Obviously, usually you would subtract these from the coordinates of A, but as A is the origin, I just square each of the coordinates of P. This gives you a quarter plus 3 over 36 plus 0, which is a third. So I found out that the square of AP is a third. By Pythag, you can use this to find that the square of dP is 2/3. Therefore, dP has length the square root of 2/3. For part 2, we need to find the angle between adjacent faces. To do this, I'm going to consider two sides, two faces, DBC and ABC. The way I'm going to do this is I'm going to treat ABC as a plane. So this is going to be the plane ABC, and I know the normal of ABC, which is dP. So this is going to be the normal, and I'm gonna work out DE such that E is the midpoint of BC, and I'm gonna work out the angle DE makes with the plane ABC. This is DE. First off, I need to find the coordinates of E. As it is the midpoint of BC, the coordinates of E are half of 3 over 2, root 3 over 2, and this should be 0, and 0. So these are the coordinates of E. Then I need to find out the DE, the vector DE. To do this, I'm gonna subtract from E. I'm gonna subtract from ED. So 3/4. And this gives you 1/4 and root 3/12 and minus root 2 over root 3. So this is the equation of dE, or rather this is the vector dE. Now I'm going to dot this with the normal dP. I know the normal dP is 0, 0, root 2 divided by root 3, subtracting, so the vector dP is this. So now I need to dot these two. By dotting these two, I'm going to find the angle between them. So dP dot dE is 1/4 this gives you minus 2 root 3. Also, another way to do this, so I found this by timesing this by this, this by this, this by this. Another way to do this is to find the magnitude of dP and times it by the magnitude of dE and times it by finally the magnitude of cos theta, theta being the angle between dP and dE. So the magnitude of dP is 1/16. So the magnitude of so 3/144, 4/9, all in the square root, and this one is root 2 over root 3 times cos theta. Rewriting this gives me so these are all plus. Rewriting this gives me 1/12 plus this is 2/3 plus 2/3, 1/12 plus 2/3, and this gives me 3/4 all in root times cos theta. Now I can equate these two. Obviously we have root 2 divided by root 3 here. Now equating this with this, it is going to give me cos theta. So if I equate minus 2/3 to root 3 over root 4 is 2, root 2 divided by root 3, cancel these two, and cos theta. So this gives me 2 root 2/3 equals cos theta. Squaring both sides gives me cos theta equals 8/9. And using the identity sine squared plus cos squared equals 1, I get sine squared theta equals 1/9. I can rewrite this as cos theta pi/2 minus theta squared equals 1/9. The reason why I do this is because if you have a look here, theta is the angle between these two, so theta is here. However, I need to find this angle. because that's the angle the line makes with the plane, because I need to find the line DE makes with the plane, not the angle it makes with the normal. Therefore, I have to subtract theta from pi over 2, or 90 degrees. Cos pi over 2 minus theta equals 1 over 9. Cos pi over 2 minus theta equals plus minus 1 over 3. However, I can eliminate the negative 1 because I know that theta is between pi over 2 minus theta is between 0 and 90, and if you draw the graph, you know it's going to be positive. Therefore, you know for certain that cos pi over 2 minus theta is 1 over 3. Therefore, cos of the angle between each of the between adjacent faces is 1 over 3. Part 3 asks you to find the largest sphere that can fit inside the tetrahedron. Maximizing the size of the sphere means it's going to touch the midpoint of every single face. So that means it's going to touch the midpoint of ABC, which is P. It's going to touch the midpoint of DBC and DAB and so forth. So if you consider things in 2 dimensions, for example, consider the triangle DPE. The radius of the sphere, say for example this is the center of the sphere. These two either are the radii of the sphere. P is the midpoint of the plane ABC, and this point, let's call it F, somewhere along these lines. F is going to be the midpoint of DBC. So in this case, we already know the length of DE from part 2. It is root 3 over 2. And we know the length of DP from part 1. It is root 2 over root 3. Therefore, we can work out the length of PE using Pythag. Squaring this gives 2 over 3, and the other one gives 3 over 4, which is equal to the square of PE. So this gives the magnitude of PE 1 over 2 root 3. If you look carefully, you can spot some similarities in this triangle. There's this small triangle and then the big triangle. These two are similar because they share this angle, and then they share this right angle. Therefore, these two angles are the same as well. Therefore, there is a ratio between the sides as well. If you consider r over 1 over 2 root 3, that is going to be equal to this side, so this section here, divided by DE. So we know this section here is root 2 over root 3 minus r, because the whole thing is dp is root 2 over root 3, root 2 over root 3 minus r divided by DE, which is root 3 over 2. Rearranging gives r times 2 root 3 times root 3 over 2 equals root 2 over root 3 minus r. Cancel these. You have 3r here, and then minus r on this side. Add r to both sides, and then obtain root 2 over root 3 equals 4r. Therefore, r is root 2 divided by 4 root 3, and rationalizing the denominator gives you root 6 divided by 12.